All right, so today in class we reviewed domain and range and we talked about what would happen if we restricted either one of those components of a function. So if we see here on the screen right now, I have y equals 2x plus 1, which is a linear function, which has a domain and range of all real numbers for everything because we know that a linear function goes on infinitely in both directions. So that's an example of a function that has an infinite domain and range. Now I can also change this here and we can look at a quadratic function. Now a quadratic function naturally has a restricted range because it does have a turning point. So the quadratic functions do not go on infinitely in both directions of x and y. What we have here is that we know that our domain is infinite in both directions, but if you see down here, our lowest y value that we're ever going to have on this quadratic function is 0, which means that our range would be that y is greater than or equal to 0. Now that just happens naturally because of the nature of a quadratic function. But what if we wanted to look at restricting domain and range? So let's go back to our line with 2x plus 1. So let's say I only wanted to look at this graph from where x was -5 to +5. So I can restrict my domain here, like doing this. And then, oh, actually, hold on. Let's make that a little bit more apparent so we can actually see where we're restricting here. Let's change that from -2 to 3. So now you can actually see on our graph here that our x values are going from -2, and the highest x value we reach is 3. Now, by restricting our domain, we also naturally restrict our range because our smallest y value is -3 on this function, and our highest y value is 7, which means that our range of this function goes from -3 to 7. I can also restrict other functions. Let's go back to our quadratic that we were looking at before. And I can restrict it in any way that I want. So here I'm just taking a little tiny piece of the quadratic. I'm saying my domain is going from -2 to 0. So I just end up with this little tiny curve. And what we can see is that our range goes from 0 to 4 because that's the only y values that we touch are between 0 and 4. We can also look at this and see what it might look like if we had an exponential function. So now let's look at 2 to the x. So now I have a teeny little restriction here from -2 to 1. So I have a tiny little part of that graph, but we know full exponential is actually starts out growing very slow and then grows very quickly. So the point being is that we can restrict anything that we want. So what we actually then moved on to do today was we started looking at using our graphing calculator because unfortunately we won't have this program when we take our Regents exam to actually see the small part of the graph. So we have to figure out how we can use the table in our TI-84 to figure out the range when we have a restricted domain. That video is coming up next.